Hello, I'm Mike Bruce, Editor-in-Chief of Defense News. Thank you for joining us for today's webcast, which will focus on Project Overmatch and how the Navy is using artificial intelligence and machine learning to maintain a tactical advantage. Thank you to our sponsor, L3Harris Technologies, who helped make this webcast possible. My guest today is Chris DeMello, Senior Manager for Engineering Management and Autonomous Surface Vehicles, Chief Engineer, L3Harris Technologies. Chris leads a team that develops autonomous surface vehicle technologies, including the Expeditionary Fast Transport prototype. Chris, thank you so much for joining me today.
Thank you for having me. It's a pleasure to be here.
I want to get right into it. I think from an international perspective, we often talk about Beijing and Moscow as being a pacing threat when it comes to artificial intelligence and machine learning. They're investing an awful lot of money there. But domestically, how are artificial intelligence and ML influencing decision-making on technology and strategy within the Navy? In other words, what role will these technologies play?
Yeah, I think they're going to play a pretty major role. It's funny, years ago, I remember when we used to talk about AI and ML, we used to talk about Skynet. It comes to mind in the Terminator movies and it's going to take over. But I think with the proliferation of information about artificial intelligence and machine learning and the real world practical everyday applications of the technology, we're starting to see a lot of decision makers think differently about how to use those technologies, especially autonomous systems. I think there's a much better understanding of where we can apply those particular technologies in a really tangible way. And I think that a lot of that is thanks to the DoD's JAIC, the Joint Artificial Intelligence Center, which is now Chief Digital and Artificial Intelligence Office. Navy leadership really understands how to use those technologies and is really seeing applications when we think about self-driving cars or self-parking cars and even robot vacuums avoiding furniture. They're seeing that I can take the Chief of Naval Operations nav plan and I can look at things like readiness, capabilities, capacity, and people, and I can attack each of those particular areas using these new technologies. So, for example, we talk about contested logistics, which is, a really important topic. You mentioned that Expeditionary Fast Transport, the EPF platform. One of the demonstrations we did was to install autonomy on that logistics vessel to demonstrate the ability to navigate commercial shipping lanes using various sensors to determine sea state and whatnot, where we can keep folks out of harm's way but still deliver logistics in a contested environment. It's funny, Rear Admiral Sobek, who's the Director of Strategy, Capability, Policy, Programs, and Logistics at the U.S. Transportation Command, was just mentioning the other day that he didn't want logistics to lag behind the shooters. And autonomy and artificial intelligence is a really great way to do that. And we're demonstrating that now with that EPF platform.
Can we talk about those demonstrations for a second, which is, do you see those as how we're going to think about artificial intelligence and machine learning going forward, that it will be these series of exercises, these series of advancements that, kind of stair-stepping our way to greater capability, or will there be these big announcements and these big major advancements where, I didn't know we could do that?
That's a great question. I actually really think that we're starting to make a lot of small breakthroughs very rapidly. I think about what's happening in Task Force 59 over in Bahrain and all of the little demonstrations. It seems like every few months, they're putting a new sensor on board. They're doing a different mission. And we have one of our vessels there, the Arabian Fox, that it seems like every 2 weeks I'm on a meeting with some of my team saying, hey, we were just asked about this sensor or this network capability. Can we get out into the water and demonstrate that? And it is becoming, for lack of a better term, sort of a spiral process, if you will, almost like software development, in that we are continuously iterating with lots of small breakthroughs. We find and we learn something, especially relative to, let's say, collision avoidance, and we roll it back in and we send it back out there. So I know we do that quite a bit. My team, especially my U.S. team, is out on the lake and the rivers in Louisiana. Every week, they're out there testing something, poking something, installing something else to try and make those iterative advances. And we are, because of that process, really moving rapidly in adding capability that really does address the Navy's future plans and how they think about the battle space, especially the contested battle space moving forward.
I think when we have these conversations about AI and ML, so much of it has to do with the future, exactly what you said, even like that Terminator possibility. But all the services, including the Navy, are using AI and ML right now. And so you talked about some examples, but how are they doing that now? And how do they build those expectations into the future? You mentioned spiral development might be one way, but I think maybe surprise some of our viewers and like what's being used today.
Yeah, when we talk about AI, ML, and autonomy, there's a lot of artificial intelligence that is being used today, lots of different algorithms to help with things like image classification. That is a big area in which the Navy is looking to navigate, let's say, passively. What if I could go into an area and no one knew I was there because I'm not actively sending out radar or sonar in any way? So especially internally to L3Harris, we're using a lot of AI and ML to do image classification. If I can see that it is a tanker vessel rather than a speedboat, now I can change how I navigate. I can target differently. I can handle my approach and my avoidance separately. So for sure, one of the biggest areas that is happening today, every day, and continuing to grow, and we're doing it as well, my team, is that image classification, passively capturing visual in the various spectrum, whether it's infrared or standard daylight cameras, and using those for navigation or for targeting or to pass off board for ISR related. So AI and ML is not a distant concept. It is something we do today, every day, all day in lots of different areas.
I think naturally, as part of this, there's also the Project Overmatch, which is one of the Navy's big initiatives, often linked to the sensor to shooter conversation, the JADC2 conversation. How do you see AI and machine learning fitting into that conversation? What role does that play? And is it data processing? Is it image recognition? How should we think of these and how they go hand in hand, if at all?
I think that's a really great question. And I do believe they absolutely go hand in hand. And more than that, I think critical to Project Overmatch's end goals is AI, ML, and autonomy. I know Project Overmatch is more than just an autonomy perspective. There's a lot of comms related with that and interconnection and networking. And we talked about JADC2 a little bit. So I think from a C5 ISR perspective, when we're talking about that battle space as a whole, and we look at AI and machine learning and autonomy, if I'm able to take a lot of autonomous vessels using a lot of artificial intelligence, and I can flood the battle space, if I can flood even the contested areas where there may not be SATCOMs available, GPS may be jammed in those areas. If I am able to use lots of smaller, passively sensing autonomous vessels, and they are constantly pulling in information and they are processing that information, if there are point-to-point comms because they are close enough still available, I can create effectively a mesh network that no one knows is there because they are now passively doing their work using all that image classification and that data processing, and they're able to pass it back. And you think about long range fires and how important that is to the Navy. Now I've created this mesh network that continues out beyond that contested battle space all the way out to where I can keep my shooters far away to be able to do those long range fire missions. But I still have all of that ISR capability, local, close in. And if they are detected, now my adversary is looking at those guys and they now need to start going active. They now need to start showing where they are. And my long range fires are still far enough away. So when we talk about autonomy, that to me is crucial to how Project Overmatch is going to achieve some of their initiatives. And then more than that, we now can use them offensively and defensively, keeping folks safe and away. And then that, to me, when we think about Project Overmatch and some of their goals, that provides capacity. I don't need a destroyer. I don't need a cruiser close in. I can, for the price of, a munition, I can have an unmanned vessel continually collecting data, processing it, shipping it off board. And even if I can't ship it off board, it can autonomously process some of that data for collection later if we needed to go that route. So yeah, I think it's crucial. And a lot of the work we're doing, my team is doing, is looking at how do I now, to me, autonomy is novel. How can I use it in these mission areas? How can I put more processing power, more machine learning capability onto those autonomous platforms to create that mesh network, to do all of the work there, and then it can be passed backwards easily.
Well, fantastic. All this, a few years ago, it sounded very futuristic, and now it's very quickly become part of reality. And so that's fun to watch. Unfortunately, that's all the time we have for today. Please join me in thanking Chris DeMello, as well as our sponsor, L3Harris Technologies. We'll take a short break. Then Defense News reporter Megan Eckstein will moderate a discussion of the Navy's use of artificial intelligence and machine learning. Thank you.
Hello, I'm Megan Eckstein, Naval Warfare Reporter for Defense News. Thank you for joining us today for this discussion on how the Navy is using artificial intelligence and machine learning, including as part of its Project Overmatch initiative. If you have any questions during the discussion, please hit the Ask a Question button to submit them, and we'll get to as many as time allows. Joining me today are Bill Drexel, an Associate Fellow for Technology and National Security at the Center for a New American Security, as well as Brian Clark, Senior Fellow and Director of the Center for Defense Concepts and Technology at the Hudson Institute. Brian and Bill, thank you so much for being here today.
Thanks, Megan.
Just by way of introduction to the audience, I wondered if you both could first just run us through your current research portfolio, kind of how you're looking at Navy uses of unmanned and AI technology, and kind of any burning questions that you have for the naval services. Brian, if you'd like to go first.
Sure. Thanks, Megan. So the work we're doing right now is focused on the idea of using decision-making advantage to get an edge in military operations. So we're looking at JADC2, Joint All-Domain Command and Control, how military forces can harness information that's available to them commercially and from military sources, how they can take that information and fuse it, use decision aids to be able to craft courses of action, and then promulgate that out to the appropriate elements of kill chains or effects chains. So what we're in the course of that, one of the things we're looking at is this idea of what we call decision-centric warfare, where the force that has a larger number of options available to it will have an advantage relative to those forces that have fewer options. And the goal of a military force should be to try to give itself as many options as possible, which should allow it to make faster and better decisions and start to constrain the options available to an enemy. So that's one of the things we're really exploring in detail, and that's come out of the work we've done with DARPA and the Navy. And so a lot of things that flow out of that are unmanned systems, the role of them, how they can be employed most effectively, and then electromagnetic warfare and how that plays into the ability to get decision advantage and do command and control and communications.
Certainly. And Bill, how about you?
My team at the CNAS is focused predominantly on AI safety and stability. So how AI new use cases are being rolled out throughout the military. JADC2 is certainly one of the major areas we see that, and Project Overmatch has a lot of potential in terms of where different capabilities can be implemented. So I'm really excited to learn more and dig into it.
Perfect. Well, before we get sort of into the meatier parts of unmanned and AI technology, maybe just, for those in the audience who are less familiar with Project Overmatch, I found it very interesting. Early last year, Rear Admiral Doug Small, who leads the effort, he was asked about Project Overmatch at an event, and he made very clear to the audience that it wasn't just about this sort of any sensor, any shooter idea of connectivity on the battlefield, but he really talked about, quote, also being able to send emails and do other things. So I wonder what you both make of, sort of the state of Navy IT, kind of what this means for how Herculean an effort Project Overmatch might be, and really how the whole Navy could benefit from Project Overmatch, in addition to this, ever connected, network of unmanned systems, kind of sensing things, shooting things, but maybe some larger impacts to the Navy.
So I'll go ahead and start, Megan. So I think, taking Project Overmatch, it's important to kind of break it up into two big constituent parts. One is the sort of communications networking capability that they're focused on. And I'll say that when you talk to the Project Overmatch team, that's kind of the main effort that they're focused on right now is how do we improve the ability of military forces to communicate with each other in the field, as well as with people back home that they need to communicate with to get analysis or to just make connections in terms of keeping the administration flowing, like Doug Small mentioned. So communications has really been the emphasis thus far in Project Overmatch, and a lot of that has to do with how do I make it so that my communication networks can be configured on the fly using software. Software-defined networking is a very hot area right now in commercial software, and they're trying to take that same set of ideas and put them into the Navy's military networking space. So the idea of configuring networks on the fly for the needs that they have, making the bandwidth align with what the mission requires. So if I have only a small amount of bandwidth required for a certain set of operations, I can take that bandwidth and apportion it to that and take other bandwidth on other networks and give it to administrative functions. So one of the challenges the Navy has had is on the servers that are on ships right now, it's sort of a one size fits all thing. So you've got big pipelines that go back to shore. You've got little pipelines that go out to forces at sea. But sometimes you need big pipelines to forces at sea and little pipelines back to shore. So Project Overmatch is in part intended to provide more flexibility to how you configure that network so that I can send all the emails home, maybe in a big batch, and then turn around and then align that same bandwidth to go support operations where I need a high bandwidth feed from a sensor in order to identify a target and maybe engage it. So a lot of it has to do with this idea of software-defined networking, configuring and composing networks on the fly, which is being done in the field as opposed to being just done back at the enterprise level back at home.
As someone who has gotten stuck on a ship and not been able to send an email off to let folks know that I'm stuck, I can certainly sympathize with that. Bill, what do you make of sort of the current state of Navy IT and how that plays into where they need to go with Project Overmatch?
Sure. Well, I think one of the biggest surprises for me, coming from a civilian background, about kind of military tech in general, maybe Navy specifically, is that you hear a lot about these kind of cutting edge, really intense capabilities that are being rolled out. But alongside those kind of mind bending capabilities, there's some really antiquated systems, and things get updated organically and incrementally, as often happens in large organizations. And Project Overmatch seems to have a pretty wide mandate. So I suspect it is a large task that's going to touch a lot of elements of technical systems that haven't been touched in quite a while.
Sure. Bill, I'll start with you for the next one because you mentioned this in your opening remarks. We hear a lot about decision advantage as sort of the intended outcome of Project Overmatch. I wonder, what you both make of decision advantage today against potential adversaries such as Russia, China, others out there in the world, and what would decision advantage really have to look like in the future as the battlefield becomes more complex?
Sure, I think that's a great question. I would say, everyone's thinking about this. China recently announced their own JADC2 competitor. Its decision advantage is sort of one of these really eminent issues across the board for everyone. I think at the present moment, if I were pressed, I would say we definitely have a kind of decision advantage at the moment, but it all depends on context. Russia and China both have very hierarchical decision-making structures and comparatively less intelligence to work with. We're seeing that laid bare for Russia right now in Ukraine. And there's evidence to suggest that China has similar issues, particularly in the difficulty of their different wings of their armed forces to collaborate and communicate due to that hierarchical structure. But the fact is, both China and Russia recognize the decision advantage we currently have and what we're trying to build. So both of them have sort of specific military documents that really call this out and aim to engage, would only aim to engage American forces where they can minimize or diminish our decision advantage. That would be limited, localized conflicts. I think a decision advantage that we should be aiming for is one that's resilient, one that's able to take those attacks that they're trying to build out for systems like Project Overmatch and is able to kind of maintain decision advantage when elements of our systems may be compromised.
Certainly. And Brian, how about you?
Yeah, Megan, to build on that, I think those are great points. So if you think of decision advantage as being able to make faster and better decisions than your opponent, then there's some things that sort of fall out of that in terms of, well, technologically, what do I need? Operationally, what do I need? One way of looking at that is, if I can make decisions at a scale and a tempo that sort of overwhelms my opponent, well, then I can certainly, maybe constrain his options and start to drive him into a position where he has to seek an off ramp. And a way to do that is to have connectivity with more of the force, have a larger number of potential units you can draw upon. It's not every sensor, every shooter, but it's being able to communicate with more of the force and then have a more disaggregated force. So you've got more tools to play with and recompose in new ways. So there's a connectivity element to it there. But the other element of it, which is complementary, is this ability to formulate courses of action. So once I kind of know what I've got available to me in the toolkit, I kind of need to know what are my options for using those tools. And to do fast decision making or on a scale, I need decision aids that are probably computer generated, right? So I need computer developed or computer assisted decision aids that help me to build courses of action using the tools that are available to me. And then I need to be able to have commanders that trust what those decision aids are telling them. And they don't all need to be AI enabled. We've built some that are not AI enabled, but they're just basically, deterministic models that figure out what the right combinations of things are. And then you can pull the trigger and maybe initiate those courses of action. So that gives you that ability to operate maybe at a scale and tempo that your opponent can't keep up with. And maybe also gives you that ability to think ahead, because one thing you need to do is be able to understand, how does this set of decisions impact the options available to me in the future? If I burn a bunch of options because I maximized my current level of fires or advantage, then I'm going to maybe disadvantage myself down the road. So I've got to be thinking about that, which computer-aided decision aids can help you do that kind of thing. So I think so those are a couple elements that come into decision advantage. These are a couple of things that are entering into Project Overmatch too, because they're now transitioning Project Overmatch in a lot of ways from focusing just on communications to focusing on command and control. So what are the command and control tools that we want to give commanders so that they can use the communications they have available to them to formulate courses of action and then implement those at a scale and tempo that maybe the opponent can't keep up with. And then the last thing I'd say is, mission command is an element of this. And Bill brought up the Chinese. I think that's a great example of a country that's moving from a more hierarchical decision-making structure to one where they are trying to give their junior commanders more leeway to pursue courses of action of their own choosing or development. That's a way to really get decision advantage also, because those junior commanders might pursue courses of action that are different than doctrine, different than habit, or what you might have predicted. So it gives you an ability to create more creativity, create a wider set of options, and less predictability for your opponent to try to diagnose. But that means those decision aids have to be pushed down to a level where O3s, O4s, O5s are choosing courses of action, and they're doing it based on what they see as the best opportunity they have, rather than basing them strictly on what doctrine says. And that gives you a decision advantage well, because your opponent can't really match that if they can't predict how you're going to respond. And we found in wargaming that really does play out in practice.
Brian, I know you've looked at some of these larger issues before. When you talk about the junior officers having that decision-making ability, the authority to kind of take the information at their disposal and decide how to go forward, they obviously have that ability right now. But these aids may present many more options to them than they're used to. How does training really need to keep up with this? That way they can make more creative decisions. They can, use the tools at their disposal to make the right decisions. It seems like it would have not only the tech development side of it, but also really a training side.
Oh, absolutely. So in the work that's being done right now, the Marines are really kind of at the lead of this. But the Navy's doing some of this as well under Project Overmatch, is getting those, single ship commanders all the way down to platoon leaders, be able to be comfortable using decision aids. And so the problem we have now is we've given them all a lot of tools. So we've given platoons in the Marine Corps a lot of UAVs, a lot of electronic warfare systems, lots of different ways they can compose their unit. But they don't have time to think through all that. They don't have a staff to help them do the course of action development like a senior commander would. And same with a ship commander. Ship commander doesn't have a huge staff to go and develop courses of action. So they need aides to help them work through that in a kind of a rapid enough manner that you're able to actually exploit the advantage that you have. And what that means is in terms of training, you've got to then get some familiarity with how the tools work, what kinds of things the tools tend to drive you toward, what objective functions they pursue. And that gets into the role of AI, because some of these are going to be powered by a very kind of rudimentary form of AI that helps them to formulate courses of action. You need to be comfortable with what the AI-enabled system is telling you and be willing to trust that it makes sense, which means you need to do it often enough and get enough reps and sets that you feel like, okay, I've reused this thing a million times. It hasn't steered me wrong yet. I kind of know when I give it an input, I kind of understand what is coming out on the back end of it because I've done this enough. And that's really what it comes down to. It's just like if you use Google Maps or Waze before Google Maps took it over. Am I comfortable using this because it's not steered me wrong in the past? And I kind of know generally where I'm going. So I'm comfortable with this course of action. So that's kind of what you need to do. And we've done wargaming where we actually evaluated that and you know how different a course of action has to be before a commander will throw up and say, no way, I'm not going to do that. I'm going to put a different set of inputs in and spin the wheel again.
Sure. Well, sort of to that point, when a lot of folks talk about AI, unmanned technologies, they're really talking about future technology, future missions, future concepts of operations when everything matures a little bit. But there are current operational needs for these technologies. As you mentioned, there are current operations with the Marine Corps happening. The Navy is going to deploy Project Overmatch on its first carrier strike group later on this year. So I wonder if you could both comment a little bit on what are those current missions that you think are very applicable for AI in particular, and how can the Navy and Marine Corps sort of start small with the technology that's available today, learn a little bit, wait till the technology matures a little bit and really grow from there. Bill, if you'd like to kick us off.
Sure. Well, I think the question of what the best use case is a really important one, because in large organizations, there's often this sort of centripetal force to go to what's the most flashy new capability, when really what you want is what do we need most and what would be most helpful right now that we have high confidence in. So some of the areas I think that are probably particularly could be useful in AI, one would be cybersecurity, detecting anomalies, particularly as this is a comms system as well. You certainly don't want enemies, particularly enemies that have stated they'll be targeting this sort of system. There could be some menial task automation. That's certainly a possibility. Early analysis on threats, that could be helpful. I think there may be limits there as to how much is possible at the moment. Logistics and maintenance, and edge autonomy in unmanned vehicles. But what I would stress is it really is essential to start small and work out from there. First of all, to make sure it's a customer-centric approach and not this sort of capability-driven approach. I think that generally when you start small, iterate, that's when you get the most effective results. And second, AI and machine learning tools generally, they're kind of infamous for their brittleness in new contexts. And the key there is to test thoroughly in one context and then to test thoroughly in another context and to build your repertoire. That'll reduce the brittleness. It'll also help the AI or machine learning system to kind of have more generalizable insights that are more generally stable for contexts that you can't test, things you don't expect.
Yeah, Megan, to build on that, what Project Overmatch has been doing thus far is really not a lot of AI. So there's some autonomy with regard, or automation with regard to network management that they've incorporated, but that's largely just automation rather than really using artificial intelligence. And then with these decision support tools, a lot of them really don't use artificial intelligence as much as they use modeling and simulation to formulate a set of courses of actions that provide options. And then there may be some very rudimentary form of machine learning on the back end that helps to understand, after you've done some actions, which ones seem to work well, which ones don't seem to work. And so the system will start to reject courses of action, that it develops that are not very similar to ones that have been chosen in the past. But you have to be careful, because that'll eventually, whittle down your choices to be only the ones that you've chosen in the past. So the whole idea by using the decision aid is to try to open up your option set. So you want to avoid having a machine learning system that's going to just start to hone down on what the optimal solutions are, because they're only doing it based on what you've done in the past. So there's some limitations in terms of how you'd want to employ machine learning on the decision aid side, but we are seeing a lot more use of artificial intelligence at the tactical level in actual weapon systems. There's weapons that incorporate some very kind of low end machine learning tools to be able to identify targets and understand which targets tend to look a particular way. Electronic warfare systems that the Navy is starting to deploy and that other services are deploying incorporate machine learning to try to formulate techniques and waveform generation that is going to be effective against an adversary, which is also employing intelligent radars and electronic warfare systems. So you're really seeing a lot more advancement in terms of using machine learning and artificial intelligence at that tactical system level, as opposed to at the larger level, because I think we're seeing that, as Bill said, these systems can be sometimes brittle. They sometimes drive you in the direction you don't really want to go. And so we need more time to think about how to best employ them when it comes to doing command control and maybe even network management.
I probably won't get a good answer to this myself due to secrecy around Project Overmatch, which we'll get to in a moment. But you two, throughout your research and the wargaming efforts that you do, I wonder, what are you looking for in 2023, whether it's the Project Overmatch deployment on a carrier strike group or just other efforts throughout the fleet? What are you looking for to see that the Navy is taking the approach that you've just outlined with starting small, learning how the technology works in very specific environments? What are you looking for to see that they are taking that approach? And are there any red flags that you're kind of looking for that maybe they're veering down, a path that you wouldn't recommend?
Well, I can go ahead and start, Megan. So so a couple of things I'm looking for are, as this first carrier strike group deploys, are they going to bring in other systems outside the carrier strike group? Because I think the focus of Project Overmatch on better managing the communications network of the carrier strike group itself is great. But it doesn't necessarily give you decision advantage. It's really about better managing the network and ensuring that your comms can be, maintained more resiliently and also maintain the connectivity back home and elsewhere. So that's what Doug Small is getting at, this idea that, network connectivity and throughput is a lot of what they're focused on right now. But they really, to get decision advantage, you've got to go beyond that to say, I'm going to have to be able to bring new units into the mix. I've got to, incorporate unmanned systems that are maybe deployed out in PAC fleet right now, but that are not part of that strike group. I've got to make it so that my force can be more recomposable. That's what gives me the greater set of options, and that makes it harder for the Chinese, for example, to understand or to predict how we're going to react or how we're going to perform in wartime. Because if you look at the Chinese strategy and doctrine, a lot of that surrounds this idea of systems warfare, where they build a plan based on how they expect us to fight. And if we can create more unpredictability there, then that's going to introduce more uncertainty, potentially better deter China. But so this ability to bring in new players, recompose the force in new ways, I think that's going to be really important. So as the strike group deployment occurs, that's what I'm going to be looking for, to see, are they looking for making a more greater optionality with a more recomposable force? Or is this just about making the strike group of today perform more optimally from a communications perspective?
Okay, Bill, and how about you? What are you looking for this year?
Well, I really have little to add to that. I think interoperability is just so essential, and being able to recombine different elements of all sorts of systems together as circumstances require. That I think in itself would be a great accomplishment, or certainly something to watch. Okay,
sure. Well, I want to address, sort of the secrecy element around Project Overmatch. As a reporter who deals in public information, it strikes me kind of funny that we hear so much about, the best in class commercial technology being incorporated, but then we have this hyper secrecy around the project. And I wanted to get your take on that. Is Project Overmatch really about the technology itself that commercial industry is providing, or is it about how the Navy's networking it together, employing it? What do you make of the reason for the secrecy, even though there is so much commercially available technology involved? Brian, if you'd like to go first.
Sure. Yeah, I think a large part of it is this idea that decision advantage does depend on what do you think you're going to be combining together? How do you manage the communication network? And getting too much into the details of that would provide information that China could use to try to take that network apart. Because China really sees, when you think of the systems warfare approach, they see our command control and communications architecture as being our linchpin and our greatest vulnerability. So if they can start to take apart those communication networks, if they can damage our ability to make smart decisions as fast as we can, then that's going to break down our force, because they see that as sort of the thing that's made us the most capable military in the world, is really our ability to manage operations at a pretty high tempo over large areas and with precision. So revealing too much about Project Overmatch might give clues that an adversary could use. At the same time, though, I think if you look at the different JADC2 efforts, and I've talked to all the services about them, Project Overmatch, I think, is the most effective one and the farthest one ahead in doing kind of what Bill mentioned earlier, which is this idea of trying to marry up what the operator needs with what the capability developers are doing. It's not perfect, but if you think about NIWC PAC out with Third Fleet and working very closely with PAC Fleet, is come up with a way to try to answer the needs of the operational commander and provide them with what's going to be most effective in helping to give them a decision-making advantage. And whereas Project Convergence and ABMS are really much more service-driven efforts that are looking at composing kill chains that the services are interested in for various reasons, as opposed to what the operational commander wants. So I think it's probably the most effective example of that customer-focused development effort that Bill mentioned. At the same time, it could be better. There could be a much more effective connection between operational command and what the service developers are doing. And that's what the most recent NDAA is directed with regard to JADC2, with the idea that we're going to create a standing joint force headquarters out at Indo-PACOM. They're going to be in charge of driving the JADC2 effort from the field. So you have the customer focus being put into the JADC2 effort. And I think the Navy is probably best positioned to be part of that.
Okay. And Bill, what do you make of sort of the secrecy element?
Well, I just say, it's a stated high priority target of both Chinese and Russian military doctrine. So I'm pretty glad that it's secret. Whenever I feel that kind of frustration of wishing I knew more, I think, well, I'm glad there are others who don't know more as well. So I suspect that the kind of stitching everything together particularly is what the Chinese, the Russians would love to know. And so I'm glad it's under lock and key, and I hope it stays that way for a while.
Certainly. Well, I'd like to put in a plug to the audience members. We have a few questions coming in, but please keep sending those in. We'd love to get to as many as we can. I'll just ask one or two more before I switch to audience questions. We think of AI and machine learning kind of in the context of helping unmanned ships. They'd be away from sailors. They really need that extra ability to operate solo. But there is a great potential to apply some of those technologies to manned ships. Whether it's reducing the maintenance burden on the crews or just helping them operate more efficiently through machine learning. And I wonder what the two of you make of how the Navy is pursuing ideas like that in terms of taking unmanned innovations and applying them to manned ships.
So I'll start to say that that's happening, and so it's just not been happening very quickly. I think the Navy is really sort of pursuing unmanned systems independently of the manned ships in a lot of ways. But there could be a lot more cross-pollination between the two. So for one example, the Navy took one of its EPFs, fast transports. They're the aluminum ferry-looking ships that are built by Austal, and they took one of those and made it autonomous using an autonomy package they got from a commercial vendor. So that now is essentially it could be an unmanned ship, for all intents and purposes. But they're likely to not really take that and apply it to any of their ships, and the Navy may just let that ship let that whole that program lapse, and then take the system off and then use the ship in its normal manned configuration. That experiment will end without any real back benefit of it. So the Navy really hasn't done a great job of taking the lessons from its unmanned ships and applying it to manned ships. What I do see, though, is the Navy applying a lot of the machine learning tools to do maintenance, predictive maintenance and evaluation of systems. Aviation has done this very effectively. I think the Digital Warfare Office initiated a great program to better manage the F/A-18 fleet, for example. And then you're seeing it on the down at the deck plate level with regard to specific systems, using it for monitoring the performance of particular pumps and other mechanical equipment that tends to wear out in certain ways over certain periods of time. So you're seeing it kind of at this very small scale in the maintenance world, and then you're seeing a lot of work going on in the unmanned world that's not really transitioning to the manned ships when it comes to things like guidance and control and automating watch standing and that kind of thing. That's been very slow to happen.
Okay, sure. And Bill, do you see any opportunities to apply these technologies to the manned part of the fleet?
Well, I think I'm glad to hear that maintenance is really kind of the leading edge on AI systems, because it is a delicate balance. There's a lot of literature out there that would say that if you over automate certain functions, you might actually end up with a less safe working environment, because you want to maintain a certain level of paranoia of failure for a organization to have a high reliability that mitigates against kind of disasters or errors. Maintenance in particular is a great thing to try to automate, though, because it's something that a lot of people that doesn't typically have that paranoia of failure, and that often falls by the wayside. So the fact that it's starting with maintenance in terms of manned ships, I think is a great place to start, and the rest actually I would be more conservative about, in fact.
Wonderful. Well, I'm going to jump into some of these audience questions we have coming in. I have a great one here, which asks, how can the Navy and DoD foster more trust in unmanned and AI technologies? And specifically, we talk about, sailors getting their hands on these technologies to try it out for themselves. But is there a way to really scale up that trust without each individual person having to kind of put their hands on it to believe that it works? Who would ever like to start first?
Well, I'll start. So I agree with them that questioner that there's a issue with regard to being able to scale the comfort with AI enabled systems. I think one thing we're finding, though, is that with the generation of sailors and Marines that are coming to the service now, the digital natives that are now part of the military have a lot more comfort with the use of digital tools and AI enabled tools because they use them in their civilian lives. And so we're finding that happens much more quickly. So as opposed to old guys like me that are, come out of a different era, that take a while to become familiar with and comfortable with trusting the system's output as something you would act upon. Younger sailors and Marines are not having that same sort of barrier necessarily. But I do think it comes down to, like we said earlier, reps and sets. You've got to give people the opportunity to use the systems, see how they advise you, how they perform, and then, understand. You got to understand their limitations and how inputs affect outputs. And I think that's part of why you do need some reps and sets, even if you're a digital native, because it's not like they automatically assume that a program like TikTok is going to be great. You have to experience it for a while, and then you say, oh, okay, well, TikTok is an entertaining way to spend time. But that's something that you don't assume that. You have to spend some time experiencing it. So I think that's one thing we need to see is reps and sets, but probably less so than you would need with older generations.
Sure. Bill, anything to add?
Yeah, I'll just add, I think the general population as a whole is really, because of greater reps and sets, becoming more aware of the kind of reliability of AI and the risks. I think ChatGPT-3, for example, has given a huge swath of the population a kind of chance to realize, wow, this is really powerful, and wow, this is I can put in some prompts that give me some strange things, and while it's obviously not a military system per se, I think that growing exposure of these kind of incidental, often corporate-driven enterprises is giving a lot of people a much it's really raising the awareness of what can go right and what can go wrong with these tools.
Yeah, and Megan, one thing I'll add is that this idea of inputs and outputs is really important. One thing we found in our wargaming is that users would pretty quickly figure out how their inputs were shaping the outputs, because they don't treat it as it's kind of a black box, but they understand what goes in and how it drives what comes out, so that they can then change their inputs if they're getting outputs that are not really acceptable or not what they expected.
Oh, interesting. I have another question here. We've talked a lot about the AI and machine learning side of things, but we have one question here asking how you expect Project Overmatch to advance and accelerate the employment of unmanned systems themselves. We're seeing a little bit of that right now with Task Force 59 in the Middle East, but what do you think Project Overmatch can do on the unmanned technology side?
Well, I think it's going to help. Project Overmatch is, just now getting into trying to incorporate unmanned systems. They've been deliberate in terms of what they've been focusing on and trying not to bite off more than they can chew, I think, which is great. But now that once they get the kind of communication understanding down, the networking management, and moving into incorporating decision aids, and then the next step is really to start to bring in unmanned systems. And so I think that's where the next challenge will be, is because you've got an unmanned system development process in the Navy that's kind of focused on a set of vehicles and an unmanned control architecture that now needs to be married up with what Project Overmatch is doing with regard to command and control of an entire naval force, like a strike group. And there's a seam there that has to be somehow sewn together between what the vehicle control and command and control and mission planning does and what the overall commander may want out of those unmanned vehicles. And so that's something that needs to happen. But I think overall, Project Overmatch is going to help because it does provide you this C3 architecture that is supposed to be more recomposable, that should offer opportunities to better integrate new vehicles. The challenge, or the issue will be, vehicles need to incorporate the sorts of data links and networks that Project Overmatch has been centered on, as opposed to using their own unique or commercial networks, which are maybe not as resilient or as interoperable. So I think that'll be something that needs to get worked through, but that's part of that seam. And I think that's one thing that the team is going to have to start working on, is between what PEO-USC and those folks are doing and what NIWC PAC is doing, there's going to have to be some marrying up.
I'd just add to, I think my understanding is that Project Overmatch and JADC2 as a whole are kind of evolving long-term ambitions. And so we're in the early stages now, but to the extent that they really are able to establish a much more robust information technology infrastructure, I think that opens up a lot of possibilities for unmanned vehicles in ways that we probably can't even guess at the moment. It's a bit like when 3G, 4G was rolled out, and prior to that, it was hard to imagine an Uber, but at some point you have enough connectivity, you have enough adaptability, and you realize, we could be doing something along these lines. Obviously that's down the road, but I suppose the ambition is to go in that direction with unmanned vehicles in particular.
Great. I have another question here about unmanned vehicles. They ask, are certain geographical theaters more conducive to unmanned and autonomous systems? And do different AORs have potentially different hurdles for operating those vehicles?
It depends on the vehicles, right? So if you're talking about small unmanned systems that maybe are more limited in their endurance, or range, then obviously more constrained theaters are going to be better suited for them. If you're talking about these larger vehicles, like the large unmanned surface vessel, medium unmanned surface vessel, large UAVs like the MQ-9, well, then those can operate for very wide theaters, so they don't necessarily need to be in geographically constrained areas. And then the issue of contestation will come into play, is how survivable is a vehicle if someone's actually trying to destroy it, capture it, whatever. So those all come into play, and I think we're finding that there's utility for small unmanned vehicles in places like the Western Pacific, as long as it's inside the first island chain. So the South China Sea, East China Sea, Taiwan Strait, those are all places where you could employ these relatively small unmanned systems effectively, as long as you've got a place to deploy them from, that's survivable or useful. But then in Task Force 59 is showing us that these small vehicles have a great utility in places like the Persian Gulf and the Red Sea, where their lower endurance or their slower speed is not really a hindrance at all. And they can be very effective. But I think we're finding that there's lots of theaters where these smaller vehicles can be very useful, including in military operations, not just in sensing and intelligence gathering. And then the larger vehicles obviously have a lot of utility across the board. But yeah, but they're all going to be, it's going to be a trade-off, because the larger vehicles are more expensive. If they get destroyed or lost, you don't have as many of them to make up the difference.
Sure. Bill, anything to add?
I think that about covers it. I think we're going to see more and more diversity of the sort of vehicles that can be fielded, that will all have kind of pluses and minuses depending the context.
Sure. I have another question here, which I think gets a lot of people talking sometimes, regarding lethal unmanned systems. Does the human have to be in the loop, or can AI and ML be trusted enough to make a lethal kill decision? And, we've heard that answer in the past, but as AI ML becomes more mature, I wonder if you see that changing in any way.
It's it's a big question, one that a lot of people are asking. The trend seems to be headed closer and closer towards more AI enabled lethal machines. There was that instance in Libya where no one's really sure if it was an entirely autonomous lethal shot. But certainly in Ukraine, that there's more and more the creep is headed in that direction. But there are a lot of people talking about it. There's a lot of uncertainty about if the kind of the feasibility of enforcing limits on that. So I don't know. I think it's a question for a lot of people to chime in on, and certainly, it's hard to say.
Well, so the DoD did sign out a new instruction this week talking about the process for getting lethal autonomous weapons approved, and it's a pretty high bar. So, but they do allow for the possibility of there being autonomous weapons, meaning not just things that like a missile that you launch, and once it's launched, it's got a certain set of targets it's going to go after, but a weapon that instead you launch it, or a system that you launch, and it makes decisions on its own as to what it's going to attack. And those have to be approved up by the Undersecretary of Defense for Policy, the Vice Chairman of the Joint Chiefs. There's a whole set of wickets you have to get through, which makes it unlikely you're going to see very many of those in the near future, which suggests that we're going to see a lot of semi-autonomous systems, which is systems where the system has either been told a very constrained set of things it can go after, or you've got a person in the loop that's making that decision at the end game. So the weapon or the system might recommend a certain set of actions, and a human has to decide whether to proceed or not. So I think that's what we're going to see a lot more of, and a lot fewer of this kind of death bot sort of running around and killing things without having an operator be able to intervene.
Fantastic. I have a question here on decision aids. Wondering if you could just have a little bit more clarity on the AI ML work that's being done in the decision aids that are being created, kind of what they look like, what the experience is for those who are using them, and how they've maybe evolved over time. That's not a brand new thing that's being worked on, but Brian, if you want to get started, but just kind of walk us through, what you're actually seeing that's being delivered.
Yeah, so there's I won't go through all the programs, and some of them are, I'm sure, classified, so I won't get into the details. But so DARPA's had a whole series of programs, right, that are AI enabled decision aids of various flavors. So we heard about the Alpha Dogfight, competition where they had a dogfighting computer program going up against a human, and the dogfighting computer program won generally, and that's a form of AI enabled decision aid. Could you say, well, I could take that AI enabled dogfighting program, put it into a cockpit with a human in there, and the human can then intervene if necessary, but the AI can drive it if necessary. There's a bunch of other decision aids, some of which Proteus and a few other programs that have been used to support the Marine Corps in developing courses of action, on the fly, so a platoon commander can figure out what his or her options are with the forces and the systems they have available to them. Those systems generally use a little bit of AI. So there's usually some kind of machine learning incorporated into them so that they can, improve over time. But like I said, you have to constrain that use of machine learning in a way that doesn't, foreclose options as you go. So the more learning it doesn't drive you into a cul-de-sac where the only actions that are available to you are ones that you've taken in the past. But that can be a programming tool. You can use that programming to try to achieve that sort of buffering, if you will. So we've seen, I mean, there's dozens of these programs that have been developed by DARPA, by the services. A lot of them are in the RDT&E world. Some of them have been fielded. So there's some systems that have been fielded to places like Air Operations Centers that are using AI-enabled or machine learning-enabled tools to help plan flight paths for tankers, be able to build parts of air tasking orders. So those systems are out there. They're usually pretty rudimentary in terms of the machine learning that they're incorporating, but they've been fielded. And then there's a lot of these in the R&D phase that are more or less designed to try to explore the space of, what can you do with a decision aid, as opposed to being necessarily something that's been pushed out to the force in large numbers.
Sure. And Bill, what do you make of the current state of decision aids and, maybe where that could go in the future with future research?
Well, I think there's a lot of long-term potential, undeniably. As far as the current state, it's another one of those areas where I don't know most of the specifics, and I'm glad I don't know, because I'm glad others don't know. Yeah, I think we're going to see more and more of it. It's a question of getting it right. And I think there are a lot of ways to get it wrong. So, a lot of iteration, a lot of testing, but a lot of potential as well.
Sure. There's an interesting question here asking about bringing allies on board, both with Project Overmatch and just kind of, more broadly, the ways that we're talking about having decision advantage, creating more better battlefield awareness. Bill, maybe if you want to kick us off, but what do you make about U.S. participation alongside allies and kind of demonstrating some of this and developing these future technologies?
Well, I think it's a great opportunity we have that a lot of our competitors don't have as much of. So I think to the degree to which we can develop tools and processes and abilities to safely have interoperable, even interchangeable systems with our allies, the stronger we'll be. That's a difficult task, but it seems to be a stated emphasis for the JADC2 program. So I'm hopeful that things will head in that direction and are already maybe we're seeing the groundwork for that.
Yeah, I agree. There's been some groundwork laid for that. I think this is one of the areas where there's a lot of risk of allies being left behind, not because the U.S. is necessarily so far ahead in the technology, but just because the U.S. force is predominant and just larger in a lot of forces in the theaters that they operate. It could end up kind of, going in their own way in terms of using JADC2 to create this different approach to warfare that's really focused on decision-making advantage and composing forces in new ways. And that means that allies that are kind of operating under a kind of previous set of doctrine and a previous way of organizing their forces and composing their forces that are more routinized or regimented means that they might be left behind because you've got this much more flexible and recomposable U.S. force, and then you've got these allied forces that are not really able to get in the mix. And so I think that's one of the problems is figuring out how do you make it so that the networking and the decision aids and the command and control capabilities of something like Project Overmatch are made available to allies so they can become part of this recomposable force as well, instead of being something separate that ends up looking more predictable to an opponent like a China or a Russia.
Sure. Well, we're almost out of time, so I just have one more quick one for each of you to quickly address. I love this question. Are we ready to not have connectivity if something goes wrong on the battlefield? If we get attacked, are we ready to not be connected as force?
So I'll say that yes. I mean, I think this gets to mission command and the idea that an individual leader is always prepared to take charge of the forces that they can communicate with and develop a plan and move forward. I think that's why these decision aids are so important, because systems like the ones that we've been giving to ship commanders and platoon leaders in the Marine Corps are the ones that they're going to use to be able to build a plan that kind of follows the commander's intent. And gives them a lot more options available when they don't have communications with the planning staff back home. Because if you're China, the whole plan behind China's systems warfare is, I'm going to take apart your communications networks, force your individual commanders to operate independently, and trust that they're going to turn to doctrine and habit and routine, and they're going to be predictable, and I can start taking them out individually in detail. But if those individual commanders are open to a lot more courses of action because they've got decision aids, they got a little bit better connectivity, at least at their level, then it's going to be hard for an adversary to predict what they're going to do. So I think that's really the key, is if you want decision advantage, it has to flow all the way down to the junior levels, where you're likely to find yourself cut off from senior leaders and the planning staffs that use them or that they use.
Great. And Bill, anything to add?
Well, yeah, I agree. And I think one of my greatest hopes for Project Overmatch, JADC2 in general, is that it maintains that ability to devolve decision-making authority quickly and to scale it to the level of communication that we're able to have at any given moment.
Perfect. Well, unfortunately, that's all we have time for our discussion today. But again, Bill Drexel and Brian Clark, I'd really like to thank you for joining us today.
Thank you very much.
Wonderful. Also, we'd like to thank our sponsor, L3Harris Technologies. And as a reminder, this webcast will also be posted to defensenews.com. Thank you so much for joining us today.
Recording stopped.